Assalamu alaikum. Can you hear my voice? Ramesa, can you hear my voice? Is my voice clear? I think there are not many people who are interested to attend this revision class. Anyways, may I start with the It's all right. You can reply with comments. The first chapter involves concepts related to how partial differential equations are formed. Like ordinary differential equation, there are two methods. One is of removing arbitrary constant from a given family of curves for ordinary differential equation. In case of partial differential equation, we remove arbitrary constants from a system of surfaces, equations given in different forms. For example, in ordinary differential equations, we had things like this. Y is equal to mx plus c or y is equal to 3x plus k. So in this case, you have a family of straight lines that pass through center and with arbitrary constant m. Differential equation is formed by removing this arbitrary constant m. This is another family of a straight line which passes through some point 0k, and all lines have same slope 3. So you make a differential equation. Y prime is equal to 3, and that's it. Now, y prime is equal to 3 is a differential equation because it involves derivative. And it says that derivative is slope. The slope is 3. All lines that have slope 3. Now, whether they are passing through this point or that point, they are passing through arbitrary points. So, similarly, when we study differential equations, partial differential equations, हमारा objective जो है वो पहला ये है कि हम family of surfaces जो है उनमें हमारे पास for example हमारे पास spheres x square plus y square plus z square is equal to say c. So this is arbitrary. So if I want to make a differential equation out of this, I will take derivative by considering z to be independent and x and y this is dependent and this is independent. So यहाँ पे एक independent variable था, तो हमने derivative लिया. अगर दो independent variable है, तो partial derivatives लेंगे. So that is the idea that we'll discuss. Another is if you are given a family of surfaces in terms of arbitrary functions, then we make a partial differential equation in the form of taking derivatives with respect to x and with respect to y. And the general differential equation that we obtain is of this form: linear, quasi-linear differential equation, where small p represent the derivative of the dependent variable. Generally, this surface given is this form, where phi is the function of u and v, and u and v both are dependent functions of x, y, z. So we obtain partial derivatives of u and v with respect to x, y, z, and special forms. This is capital P, this is capital Q, and this is capital R. And with that, you have dou z by dou x and dou z by dou y, denoted as P, small p, and capital small q. And this makes the differential equation. And we'll be discussing exercise problems in exercise 1.1b very soon. So we have in second chapter the kind of differential equation that we obtain in the first chapter. इस तरह की differential equations जो हैं जो कि इनको solve करना is the topic of the second chapter, and the method used is due to Lagrange. And we have already introduced these notations, and we proved somewhere that we can obtain independent solutions from this equation by making some auxiliary equations. So from here, how to obtain auxiliary equations is one of the interesting part of this chapter. We are given equations of this type, and once we know that how the auxiliary equations are obtained, solving a problem, we just write down from given differential equations dx upon coefficient of small p, dy upon coefficient of small q, which is capital Q, and dz upon capital R. So these are the auxiliary equations, and then we go for different working rules depending on the type of differential equations. There are four types of methods for four types of differential equations discussed in this chapter. I restricted to three types, and one situation where we had more than two independent variables. So, for example, in this set of auxiliary equations, x and y are independent variable and z dependent. So if we have more independent variables, we will have more ratios of this type. The first working rule that we have considered, we will consider problems in 2A. I think before I go into a discussion of this, let us see that differential equations banate kaise. Okay, so I move to exercise 1A. Can you see this sheet, which is headed exercise 1 bracket A? Can you see it? Okay. Now we have considered some problems from the exercise 1A either exactly the same way or making slight changes. Z is the dependent variable, and here T and X are the independent variables. No, A and P are. P दो दफा आ रहा है. P and X are independent variables. A and P are arbitrary constants. So arbitrary constants remove करना है to obtain a differential. Z is a function of X and Y, so we take the derivative with respect to X. When you take the derivative with respect to X, X is not involved here, X is involved here, so cos Px, the derivative P cos Px. And we see that if we take a derivative another time with respect to X, it will, the result will come into the original form with a negative sign. So differentiate this again with respect to X. Another P pops out from the trigonometric function, so it becomes P squared, and the derivative of cos is minus sign, so it becomes this. So second derivative with respect to X comes out to be this. And if you work out the first and second derivative with respect to T, now T is present in the exponential part of the function. So first derivative brings one P down, the second derivative brings another P down. So both the derivatives with respect to X and T of order 2 are of same shape except for the sign. And that means if you add them together, you will get 0. And this is a differential equation because it involves derivatives. So this is one way, that is, we eliminate arbitrary constants. This is another form of the same type of question, and you can understand. By the way, I will share this recording as well as all these files that I'll be discussing today on the LMS. Recording will be going to my YouTube channel, जिसका मैं आपको link भेज दूंगा. Good. There is someone else coming to the class. Good. Okay. We can consider many different situations where arbitrary constants are involved, like A and B, and independent variables are in the shape of x cubed, y cubed. You take the derivative with respect to x, you take the derivative with respect to y, and see that from this result of derivative with respect to x, the arbitrary constant A can be written in this form, and the derivative with respect to y and the value of arbitrary constant B can be written in this form. And then you substitute both these values of arbitrary constants here in the original equation. When you substitute that in the original equation, so you ultimately get a differential equation which does not involve arbitrary constants and involve only partial derivatives. So what is the objective? The objective is something like this. Okay, you have got some equation of some system of surfaces जिसमें एक arbitrary constant हो, दो हो, तीन हो, चार हो. So what you have to do, you have to obtain fx. So whatever fx is, that will involve some arbitrary constant, you go for x, fx के अलावा fy. You don't go for fz. This fx is just tau z by tau x. This is tau z by tau y. Sometimes when you go for tau y square z by tau x square, our notations are such that we write this as p, write this as q, we write this second derivative with respect to x as r, and mixed derivative. If I have mixed derivatives involved, S is the rotation and second derivative of z with respect to y and t. So we use these kind of letters to simplify writing down differential equations. Major two technique that we use is that हम given differential equations है, किसी तरह derivative लेकर arbitrary value constant की equations मालूम करें. If we can find the value of arbitrary constant in terms of independent variables and derivative, then arbitrary constant values in terms of functions of independent variables and the partial derivatives substituted in the original equation, and we get, in simplifying, we get the corresponding differential equation. So here is a bit tricky situation where we are given equation in the form 4z is equal to ax plus y upon a plus b whole square. The arbitrary constants are a and b. Now this can be simplified in different form by opening this whole square, a plus b plus c whole square. या उससे पहले आपने LCM ले लिया तो a square ये अलग हो जाएगा और ऊपर का square खोल लें, whatever. Once you have simplified this form, you take the derivative with respect to x of z, derivative of z with respect to y, and convert the right hand side that you take derivative as with respect to x and with respect to y as simple as possible. And from the first equation, we note that we can obtain the value of a in a form which is a very simplified form. And from the second equation, where we, in fact, जब हम derivative ले रहे हैं respect to x or derivative ले रहे हैं with respect to y, in both cases, जब हम ये LCM लेंगे तो ये constant b जो है वो ab बन जाएगा, जिसकी वजह से partial derivative लेते हो b दोनों दफा गायब हो जाएगा. That means we have to work with only a. So with respect to x, you have this situation. With respect to y, you have a similar situation. That means the partial respect to x and respect to y have the same value. So the ratio is 1, and that forms a differential equation. Not simply this is equal to this, but you can also write down this as product. Now, product in the form, when you look at dava z by dava y, this whole thing is under the root of z divided by 2 and working or keep 2 as it is here. We have here a square x y plus y plus ab, and this whole thing is the square root of the right hand side, except for the a. So आप इसके LCM लेके उससे काम कर सकते हैं, and you will get ये जो part है ना, ये वाला part ये गलत किया हुआ है. They are not exactly equal. Partial respect to x जब लोगे ना इसका, so you will get 2ax square, और with respect to x में ये वाली तो term नहीं आएगी. क्या किया हुआ मैंने डायरेक्टली इसका डेरिवेटिव लिया हुआ है. Let me work it out here. The problem was 4z is equal to ax plus y upon a. Ax plus y upon a plus b whole raised to power 2. So I said that LCM ले लें x square plus y plus ab whole raised to power 2 upon a square. So I can write down 4a square and take the derivative. Dava z by dava x. So now I have to take the derivative of this. 2 times a square x plus y plus ab, yani power ka derivative multiplied by the derivative of the function inside. So that is only a square. So we see that there are some simplifications involved. एक ही टर्म है जिसमें x है तो डेरिवेटिव्स का ये कैंसिल आउट होता है इससे, ये कैंसिल आउट होता है इससे. What is left here is simplified a square x plus y plus ab. और अगर मैं यही काम with respect to z करूं, so for a square dava z by dava y, again I will have a square x plus y plus ab raised to power, so power का derivative हो गया, into derivative of the inside function 1. And in this case only this changes. So एक result मेरे पास जो आ रहा है, that is 2 dava z by dava x is equal to this bracket. दूसरा रिजल्ट जो आ रहा है वो 2a square, इसमें से खत्म हो गया, dava z by dava y into bracket. इसके अंदर this thing is equal to this thing. So 2 dava z by dava x is equal to a square dava z by dava x. That tells me that the value of a square is equal to what? Dava z by dava x cancels, so a square is equal to 1, or a is equal to 1. So value of one arbitrary constant is obtained. Now, I cannot obtain the value of the other arbitrary constant. So you work out how that dava z by dava y can be handled differently. Can it be handled differently? So इस तरह की जो tricks हैं यहाँ पे आ जाती हैं. I consider this here कि जो मैंने bracket में लिखा हुआ है वो ये है. So from here I can write down 2 root z is equal to the root of this bracket. And what that bracket is? A square. अच्छा हाँ, मैंने जब ये किया था तो a square कहाँ से आ गया था? This a square is not there. This a square is not there. This a square doesn't make any difference except for this part. Except for this part. अच्छा, ये a square जो है गलती से आया है. So we had a x plus y plus b. अच्छा हाँ, a square LCM लेने की वजह से आया था. अगर मैं ये LCM को as it is रखूं और ये a यहाँ रखूं, तो this is what is 2 under root z divided by a. So you can say that this bracket value is 2a under root z. And that gives us the results that we had here. Now, so we see that sometimes the elimination of the arbitrary constant becomes very, very tricky. It seems very simple. Ax square plus bxy plus cy square, partial with respect to x, partial with respect to y. This involves AB, this involves BC. Another partial and we get arbitrary constant value, arbitrary constant A value. You take different derivative with respect to y again, and you get the value of C in terms of derivatives, value of A in terms of derivative. तो A की वैल्यू भी आ गई, C की वैल्यू भी आ गई, B की वैल्यू रह गई. Now, once you get the value of A, you can obtain the value of B by substituting the value of A into this derivative equation. So in this derivative equation, जब आपने इसमें रख दें, so B is dou Z by dou Y is equal to Px plus 2Cy. So C की वैल्यू इसके अंदर रख दें या A की वैल्यू इसके अंदर रख दें. So ultimately you will get the value of B. So value of A from here, value of C from here, value of B from here, all substituted into the original equation, and you will have a differential equation that does not involve arbitrary constants. Working out things sometimes becomes very complicated, but at others it's not that complicated. We can have very simple question and we can have very complicated. Another that involve two arbitrary constants. So derivative with respect to x, say A आ गया. Derivative with respect to y, say B आ गया. So original equation में A और B की values रख दें and you get the result. So some problems are ये क्वेश्चन नंबर 7 जो है वो यहाँ मैंने लिखा हुआ है, लेकिन इसका सॉल्यूशन जो है अगले पेज पे है. It involves a bit complicated manipulation, algebraic manipulations. लिहाजा यहाँ ये जो लिखा हुआ है this thing, जिसको हम alternate notation में यूं लिख सकते हैं 1 upon z minus x square upon y. So this is not only complicated, and this problem is not only complicated in terms of algebraic manipulation, but the function involved. So मैंने वो function जो है उसको लिखा ही नहीं, और जो right side है उसको, क्योंकि हमने जो वर्कआउट करना है वो तो right side function पे असल में करना है. When we take the derivative of this, what will happen? This will remain as it is and then multiplied by the function inside. So उसका derivative respect to x लिख लिया. Right side per derivative respect to x is simple. So from here we derive the value of A. Then again take the derivative respect to y. So this e power something will remain as it is, or something का derivative respect to y लिया जाएगा. And this involves इसमें भी y है और इसमें भी y है, तो दोनों जगह y involve हो रहा है. So that I write down the value of b upon y square as this function, and this term goes the other side, and we simplify that together. So there, I'm not going into the details, बस ये बता रहा हूँ क्या अप्रोच इख्तियार की गई. A और B की वैल्यूज मालूम कर ली गई और फिर ओरिजिनल इक्वेशन में A और B की वैल्यूज रख दी गई. ये एक्सपोनेंशियल फंक्शन जो है ये थ्रू आउट कैंसिल हो जाएगा, and you will get ultimately after algebraic manipulation this kind of a result. Sometimes geometrical conditions are given that from which you find out the differential equation, partial differential. Spheres of radius 4 with centers on xy plane. तो XY प्लेन पर अगर सेंटर्स है आर्बिट्री, तो उनके कोऑर्डिनेट्स कैसे होंगे? सो इनके कोऑर्डिनेट्स में z कोऑर्डिनेट 0 होगा, a और b आर्बिट्री होंगे, सो स्फीयर्स की इक्वेशंस बनेंगी x माइनस a होल स्क्वायर प्लस y माइनस b होल स्क्वायर प्लस z स्क्वायर 16. We take the derivative with respect to x, extract a from there, or x minus a from there. Derivative with respect to y, so extract y minus b from here, और original equation में x minus a और y minus b रख दीजिए, simplify कीजिए and you'll get the result. There are more problems and I'm not considering discussion on all of them. These are some examples for forming differential equation using eliminating the arbitrary constant. The second aspect is eliminating arbitrary functions. So we see that we may be having problems of this type. Z is equal to e power mx, which is a known function, and phi of xy. So there is another function which involves the terms of x plus y. I don't know, it is only x plus y whole square, or it is 1 upon x plus y, or whatever. I have to eliminate this arbitrary function, unknown function, to obtain the differential equation. So I take the derivative with respect to x. When we take the derivative of such functions with respect to some variable, our approach is, अच्छा इसका तो डेरिवेटिव हमने सीधा साधा लिख लिया, ये फाई एज इट इज लिख लिया, फिर ई पावर एम एक्स को एज इट इज छोड़ दिया और फाई का डेरिवेटिव हम फाई प्राइम लिखते हैं, एंड एक्स प्लस वाई इज देयर, एंड देन डावा बाय डावा एक्स of x plus y, and that will give you only one. So that is the derivative with respect to x, and this is with respect to y. And we say that in both of them, phi prime x plus y is there. So phi prime x plus y, partial respect to y may be here, partial respect to z may be here. So manipulation is easy. I told you that z with respect to x is written as p, z with respect to y is written as q. So what have been done is that इसमें से zx minus this part, what is this? E power mx phi of x plus y divided by zx is equal to this plus e power mx phi prime x plus y. इसमें मैंने गलत किया हुआ कुछ थोड़ा सा. It will be m e power mx. No, it will not be, because this is involving only x, so this will not be there. That's all there is there. Phi prime को यहाँ से निकाल के यहाँ डाल दें, phi को यहाँ से निकाल के यहाँ डाल दें, so that arbitrary function will be removed, and after simplification we'll get only this. So now you have some examples of arbitrary function, derivative with respect to x, f prime into derivative of this is 1. With respect to y, derivative of this into derivative of x plus ay, तो उसमें से a आ जाएगा. So you have set x is zy is equal to zxa derived from these two results, and the differential equation is this form. Sometimes we have more complicated functions involved, functions of functions. So the trick is same. Take the derivative with respect to x, derivative with respect to y. एक से f prime की वैल्यू ली जाती है, and after simplifying, zx की वैल्यू निकाली जाती है, zy की वैल्यू निकाली, and then substitute in general. We from equation of partial derivative with respect to x and equation of partial derivative with respect to y, इसमें से f prime जो है वो eliminate करते हैं, and algebraic manipulation के बाद जो equation आती है that involves only derivatives. Okay, z is equal to f of x y upon z. So partial with respect to x, f prime लिखेंगे और x unknown function का हमेशा derivative f prime लिखेंगे. Then inside function के derivative with respect to x. So x y के derivative y only. With respect to y में x y के derivative x only. So eliminating f prime x y upon z, and then you get, after algebraic manipulation, the simple result. So I hope you can, after this brief discussion, you have some better idea how to make differential equation, removing arbitrary constants or removing arbitrary functions. So every time you have to consider partial derivative with respect to x, keep track of the arbitrary function, partial with respect to y, keep track of arbitrary function. And you see that here, arbitrary function and arbitrary functions derivatives both are involved because it's product. Arbitrary function is involved in a product. So when you add these two, this term cancel out, and you are left with 5 prime. Now, once you have got 5 prime, 5 prime can be replaced in any of the equation that contains 5 prime, whereas phi can be obtained from the original equation, and then you obtain an equation where neither phi, the unknown function, nor its derivative is involved. The rest is algebraic simplification, and you get always in what form? Function x y z into dava z by dava x. Function of x y z into dava z by dava y, and function of x y z. So this is how we make differential equation from given. Now, after the topic of forming partial differential equation, how to solve this kind of partial differential equations that we have obtained in chapter 1 using Lagrange method. So our method is dependent on given a differential equation, convert it to auxiliary equation, and there is a proof for how you get these auxiliary equations. But once you have this, you just apply them on the problems. A simple demonstration of that